Hello, this is Scholar Strife doing some math today in geometry. We're going to be looking at properties of chords in circles. So let's start off with a circle. And let's have two chords. A, B, C, D. So in the same circle or in congruent circles, two minor arcs are congruent if and only if their corresponding chords are congruent. So we're talking about these two minor arcs here, A, B, and C, D. These arcs are congruent if their corresponding chord is also congruent. And the backwards works too. If the arcs are congruent, then the chords are congruent. Okay, theorem 10.4. If one chord is a perpendicular bisector of another, then the first chord is the diameter of the circle. Alright. So what they're saying is, if one chord is perpendicular to another chord, so if one chord is the perpendicular bisector, so perpendicular means they form right angles, all four right angles, and bisector means split into two pieces. That means the first chord is the diameter of the circle. So basically, let's call this AB, CD. AB perpendicularly bisects CAD, CD. If that's true, then AB is the diameter. Okay. Not only that is true, if a diameter, so here's the diameter, AB again. CD. Okay. Then the diameter bisects the chord. So split into two pieces. Congruent pieces. And the arc gets split into two congruent pieces. So arc CB is congruent to arc BD. Okay. And then lastly, in the same circle or in congruent circles, let's do the first one again, A, B, C, D. Two chords are congruent if and only if they are equidistant from the center of the circle. So if this line, that's perpendicular, is the same as that line, which is also perpendicular, then those chords are congruent. So let's take a look at examples involving these properties. So example 1, in the diagram, circle A is congruent to circle D. Okay, they both have the same radius. BC is congruent to EF. And the measure of arc EF is equal to 125 degrees. So this looks like an arrowhead, but just remember it's a curve. This is a curve, an arc. Find the measure of arc BC. So because, so this is 10.3 here, theorem 10.3. So because the circles are congruent and those chords are congruent, that means their arc measures are the same. So the measure of arc BC is 125 degrees. Example 2, use the diagram of circle E to find the length of BD. Okay. So the line AC diameter is perpendicular to BD. If it's perpendicular, that means it's split in half. So if FD is 6, then BF is also 6. That means BD is 6 plus 6, which is 12. Okay, checkpoint 1. In example 3, suppose AB equals 27, EF. Did I miss something here? That's odd. Let us come back to checkpoint 1. Yes, because I think... Yeah, let's do example 3 first. And then we'll go back to the others. Example 3. In circle F, AB is the same as CD, which is 12. Find EF. Okay. So because these chords are congruent, that means GF and EF are the same. So that means 3x is equal to 7x minus 8. That means negative 4x equals negative 8. So that's me subtracting 7x to both sides. Divide by negative 4, and we'll get x is positive 2. But the answer we're looking for is the length of EF. Okay, EF is 3 times x. So 3 times 2 is 6, and that is EF. The length of EF. Okay, now let's go back to our checkpoints. Checkpoint 1 here in example 3, which is what we just did. Suppose AB is 27 and EF equals GF is 7. Find CD. Okay. So if let's draw that picture really quick. That same picture. So they're telling you that this is 27. This piece is 7. That piece is 7. Okay, and they want to know what this piece is. Okay, so because they're both equidistant from the center, same distance, that means the chords would be congruent. So if AB is 27, then CD is also 27. Checkpoint 2. So we have 2 chords that are congruent. They have the same distance. Okay, that means their arcs are also the same. So RS should be same thing as TV. And they tell us that TV is 121. That means the measure of arc S is also 121 degrees. Checkpoint 3. Find the measures of arc CB, EB, and CE. CB, EB, and CE. So they want this piece, they want this piece, and then they want the whole piece. Okay? So because we know that this is perpendicular, this right angle here, and it's perpendicular to the diameter, that means they get split into, this chord gets split into two congruent pieces, and the arc gets split into two congruent pieces. So 4x is equal to 80 minus x, which means 5x is equal to 80, so x is equal to 16. Now that I know what 16 is, or x is, I can find CB, which is 4 times 16, which is 64. Okay, and that means EB will be the same. And therefore, the two combined together is 64 plus 64, which is 128. Hopefully this helped you out. Have a good day.